Good morning, everyone. Can you all hear me? Thank you. Let's just give about 3 to 5 minutes and wait for others to join, and then we'll be able to start. Is that okay? Okay, sure. Just 5 minutes. I think around 35 minutes past, we will start. In the meantime, let's just wait for others. Thank you. Hamba kaloku babe. Uzovela ekamereni. Njani uba ningazifaka abantwana bafuna undibona babe. Okay, let us start now. Let us start now. I think everyone who wanted to join the class, who had intentions of joining the class, have actually joined our class. Let me switch this thing off so that it doesn't disturb us. Okay. If you still remember, in our last class, we talked about decimals. And we said that a decimal, it is a way of writing a number that includes a decimal point. That's what we talked about in our last class. And we mentioned, let me close this one off too. Let me take this one off too. Okay. And then we said that if you have a number of this kind, let's say you have this number here. I hope you can see. Yeah, I think you can see. Can you see the screen? Just raise your hand if you can see it. If you can't, you can just show a funny face. Can you see clearly from the screen? Okay, see. Now let's say you have this number here, which is 2.1. What usually happens is that so many things that we're measuring, if we are measuring your bank account, we cannot use fractions and we say that you have 2/5 rand. So we usually use decimals to represent the money that you have or the balance that you have in your account. So that is one reason why decimals are so important. And we said that when a number is written like this, which is 2.1, you can see there is this little dot in between these numbers. And we said that this one here, it is a decimal point. That's what we mean by a decimal point. It is that little dot that is in between the numbers. And we said that the number that is written before the decimal point, it is a whole. So this one tells you how many wholes you have. So this one is the number of wholes. And when we start talking about this number after the decimal point, that number, it is a fractional part. That's what we said in our last class, if you still remember. And of course, we continued and did so many things, and we even talked about writing in words these numbers here. That this one here, it has 2 wholes plus a tenth. So those are the things that we're actually talking about in that class also. And we moved on and we started to talk about addition, subtraction, multiplication of decimals, of which that one I only recorded a lesson and I said you must go through it. How many of you actually went through those 2 videos? Can you please raise your hand if you did not do what I said you must do? Please raise your hand if you did not go through those videos. Just raise your hand. Esinago, I think, is one of the people who did not actually do this. And then we also have Batabile. And we also have who else? Linamandla Ncube, and we also have who else? Linamandla Sibabalwe. Okay, I can see that a couple of about 5, 6, 7, 8 few individuals who actually did not go through the videos. I would say that please go through those videos. It's just the addition, it's just the 4 binary operations on decimal numbers. Please go through those things. We're not gonna go through them here. Here today, I want us to deal with the conversion of decimals. We're converting a decimal number to a rational number. That's what I want us to talk about today only. And then in our next class, we go to exponents and we go further and further into algebra. That's what we will actually do now. We spend too much time. Please find time to do those 2 videos, please, so that you don't end up getting left out. Yeah. And then today I want us to start by talking about conversion of terminating decimal numbers to rational numbers. When I'm speaking of rational numbers, as I said in our previous class, that a rational number, it is a number that can be written in a fractional form with both numerator and denominator integers such that the denominator is not equal to 0. Or in simply put, rational numbers in this form, think of them as proper fractions, improper fractions, and also decimals that can be written in terms of proper fractions and improper fractions. Think of them like that. And how do we convert decimal numbers to rational numbers? Of course, we have this series of steps. First, I'm going to read them and try and explain how to do this so that at least you get a clear picture of what is happening. There are a series of steps that you need to follow. Of course, this one over here is just the summary of these steps. I will try and share these notes so that at least you can have these, you can write these things down. First step is the whole number before the decimal point becomes the whole of the mixed fraction. So we take this decimal, we convert it first to a mixed number, and then from that mixed number we go to a rational number. That's what we are actually doing here. Now, how do we get this mixed number? I wrote this series of steps, I think about 9 of them. At least all of these things, you will be able to write them. I will share the notes again. But what is important here, I want us to focus on how do we actually do this thing of converting a decimal number to a rational number. The first thing that I want you to know, more than anything, I want you to realize when you have a decimal number, the number before the decimal point, it is the whole part. And the number that is after the decimal point, it is a fractional part. And this dot here is actually separating those two. It is a decimal point. So what do you first do when you want to convert a decimal number, which is terminating? In other words, the numbers after this decimal point, they stop. Like you have 1, 1, 1, 1, and then you stop somewhere. So that is what we mean by terminating. They stop. So how do you do? Excuse me. At least flu cannot travel through a microphone and come to you guys. That's why it is safe for me to be here online, better than to be just amongst you. So this number here, first, this is a decimal and want to convert it to a mixed number. A mixed number, it is a number of this kind here. There is this portion that is here, this one here, and then this one is the whole part. And then there is also this portion over here, which is the numerator, and then this one here, it is a denominator. This is a mixed number. Now, how do you convert this to a mixed number? This one is a whole part, and this number that is in front of this decimal point is a whole part. So you take it and then you place it here because it is the whole part. So this 2 here, it goes inside here. That is the whole part. Again, when you go to this decimal here, which is 2.11, this 2 here, it is the whole part. Of course, it is the one that goes here. Right. The same thing here, you can see is only 2 before the decimal point, so you just put it here. I hope you get this part. That when you're actually having this whole part, it is the one that goes to this little box just before this fraction here in order to get to this mixed number. Anyone who's not getting this, just raise your hand. Linamandla, are you raising a hand? Or you forgot to drop it? Linamandla Ngbi. Anyone who's getting it? How to get this 2 in front of this mixed number? Anyone who's getting it? You can bounce me up, thumbs up, whatever we call it. That if you have this decimal here, you just take this whole part and then you put it here. Anyone who's not getting that part? Oh, people joined the class and then they slept. I'm speaking to myself.
No, sir.
Okay. Do you get how to get these 2 here from a decimal?
Yes, sir.
Yes.
Okay. Now, how do we end up getting this numerator here and this denominator? Actually, these things, they are very easy. Trust me. If you can actually make sure that at least you listen to this part, then this whole thing will be so much easy for you. Trust me. You take this 2, you place it here. And then you take all the numbers that are just after this decimal. You place them as a numerator. As you can see here, we have only 1. So you place a 1 here, which is the numbers that are after the decimal point. Here we have 1, 1. So here you're going to place a 1 and another 1. So you take that number as it is after the decimal point. And then, of course, here you have 1, and then you have a 2, and then you have a 3. Yeah, so 1, 2, 3, it is actually our numerator. I hope you get this part, that you just take this number that is after the decimal point, you place it as a numerator. Now, a denominator is very simple. It's going to have 1 and a bunch of zeros, 1 and a bunch of zeros, 1 and a bunch of zeros. Now, you ask yourself how many numbers are after the decimal point. Here, you can see that there's only one number, which is 1. So, we are going to have only 1 0. Here, you have 2 numbers after the decimal point. So, we're going to have 2 zeros. Likewise, here we have 3 numbers. Then you're going to have 3 zeros. I hope you get how easy this thing is. Very, 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 very easy, this thing. It's not hard at all. Just to confirm to you, we have a calculator here that is going to actually tell us if are we telling the truth or are we lying. So if you look at this here, let's say I have a 2, and then I have a 1, and then I have a 10 as a denominator. Can you see that this is simple as 2.1, which is that? Just take this as it is, you make it as a whole here, You take this number after the decimal point, you make it a numerator, and then of course you take this place a 1 in the denominator, and then you actually add how many zeros we have. We have one number that is after the decimal point, so we place a 0. That's how easy this thing is. It's not hard at all. It's actually not hard at all. This is very, very easy. And as I said before, now the next thing that you have to do, you have to convert now this number here to actually a rational number or a fraction. I said this in class that to convert this to a rational number, this is very simple, just a fraction. You just say the whole part times the denominator plus the numerator. You will get the new numerator. As you can see here, 2 times 10, it is 20. 20 plus 1, it is 21. As you can see this fraction there. And the denominator, you take it as it is. Now you have a rational number. That's how simple this thing is. It's not hard at all. You just take this 2, multiply by 10, plus a 1, that is your numerator. You take the denominator as it is, you place it as a denominator. You will see that this is so much easy. And even when it comes to this one, you just say 2 times 100, that is a 200, plus 11, that's 211. So you are going to have a 211 divided by 100. That is going to be a new rational number. Okay, let me say I have a 2.11. As I said, 2.11. You can see that this is a 211 divided by 100. That's how easy this thing is. 2 times that plus that, that's a new numerator, and the denominator, you take it as it is. Another thing, like I said here, you have a 2. No, let me do this. Shift, place this mixed number. You have a 2 there, and then you take this number as it is, so you have a 1, 1. And then the numerator here, you have a 1. How many zeros? I count how many numbers. I have this number and that number. I have 2 of them, so I have 2 zeros. Of course, when you look at this, you get the same thing. That's how easy this thing is. Is there any question so far? If you have a question, please ask the question so that we can move to other examples, as you can see here. Okay, if viewer, Bali, please, what is your question?
Hi, sir. Doc, I was going to ask Indobana, when it comes to the denominator, are the zeros determined by the number before the decimal point? Not like entirely or zonke number as nas.
These zeros.
Yeah, the zeros good denominator. Yeah, those ones.
Okay. What is happening here? Please don't unmute yourself so that we can talk, and then. But Tabile, we don't want to see what you are doing. Please close your video because I don't want to see what Limbombo boy was doing in your room there. So I really don't want to see that. Okay. We are saying, Mbali, how many numbers are after the decimal here in this 2.1?
2.1 and they 2.
After the decimal point. This dot is a decimal point.
Calculator. Oh, 1.
Yeah, there's only one number that is here.
1, yeah.
Yes. So we are going to have only 1 0 because there's only one number. If you look at this one here, how many numbers are after the decimal point? Or decimal point is this dot here. How many numbers? How many numbers after this? 2. So we are going to have 2 zeros in the denominator.
Okay.
You get it?
We only focus on the numbers after a decimal point, not the ones before.
Yes. Yes, we only focus on how many numbers after the decimal point. We don't focus on these ones before the decimal point.
Okay.
Right, thank you. Thank you that you are getting this. Then we can move forward. Let us look at this 0.4 here. Is there anyone who can give us a try how to convert this 0.4? Just unmute yourself and just try it out. Just try it out. There's nothing to be ashamed of in this thing, because the moment you get out all the wrong answers out of your system, the moment that you'll be able to keep the right answers. Anyone who want to try how to convert this one? Just this one. Mbali mfethu ngose ndikuthembile uba uzovela ushaye nje le. Anyone want to try? Remember what I said here. I said that the first thing that you have to do here is to realize the first number that is here. It is the whole part. So the whole part goes to the whole number part of the mixed number. That's what I said. And then the number after the decimal point, all of it, it goes to the numerator. And then the denominator, there is a 1 there, you place a 1, and then you count how many numbers are after the decimal point, and then that is going to be the number of zeros you place. As I said here, you have one number, so you will have 1 0. As you look at this one, the whole part is 2, so the whole number part is still going to be 2. You take this number after the decimal point as it is. Asemahle, we don't want to see what you're doing. Please close the video there. And then we have this 1 1, so you're going to place a 1 1 there as it is. The denominator, you place a 1. How many numbers are after the decimal point? We have 2 numbers, 1 and a 1. So we are going to have 2 zeros. That's how easy this thing is. It's not hard at all. Let's come here. Please unmute you, all of you. Okay, before I do that, let me just confirm this. In order for us to convert this to actually the rational number, we have a fraction, right, as it is. You just say 2 times the denominator, which is a 20, plus a 1, so you have a 21. I think I've also explained that. Just wanted to repeat it. And then the denominator, you take it as it is to come here. Now, please unmute yourselves. I want us to talk about this one here. Please unmute yourselves, guys. Please. Just for a moment. Okay. What is the whole part here in this decimal?
0.
Okay, thank you. Let me first do this here. And then I have a numerator. And then I have a denominator. So the whole number part is 0. So it goes here. Is there anyone who's not getting that part?
No.
Okay. Now, what is going to be our numerator here?
4.
Yes, we are going to have a 4 there. And then what is going to be our denominator?
1.
We're gonna place a 1. We always place a 1, right? And then how many numbers are after the decimal point?
1.
So we are going to have 1 0 here. Are we getting it?
Yes.
Okay. Now let's convert this to a fraction. How do we do that? We multiply this and the denominator, we add that. The denominator is kept as it is, so we're still gonna have a 10 there, right?
Yes.
Okay. What is 0 times 10?
10.
0 plus 4.
4.
So we get a 4 over a 10. Is there anyone who's not getting how we got 4 over 10?
No.
No, that is what I was saying. Now, because we know that 4 is the same as 2 times a 2, right? And we know that 10 is the same as a 2 times a 5. And we can see that we have a 2 in the numerator and a 2 in the denominator. We cancel those things out and we are left with a 2 over a 5. That is what we are talking about. So we don't leave our answer here. We always leave it in the simplest form. Do we get it?
Yes, sir.
Okay. Do you want to try this one? 0.7.
Yes.
And then tell me the answer. Okay. Please mute yourselves. Now I'm gonna hear things. I don't want to hear your things, please. Yeah, because what's gonna happen now? I will start to hear your things, and now when I'm starting to make an example about what you are saying, now it will be like I'm personal. I'm being personal. I don't want to hear your things. I really don't want to. But Tabile, what is the answer? 0.7 is? Anyone who have an answer of 0.7, please.
7 over 10.
7 over?
Over 10.
Oh, thank you. Thank you, sir. Thank you very much. So when it comes to this, I've already simplified this as solutions. This one, we did it all together. We are fine there. And then this one here, all we can see, the whole part is 0, so we have a 0 there. And then the 7 goes to the numerator, and then we place a 1 there. And then after that, you can see that we have only one number after the decimal point, so we place 1, 0. And of course, when you multiply 0 by 10, that's a 0, plus 7, that's a 7, all over a 10. This one is already in the simplest form, so you can leave it as it is. Is there anyone who's not getting this thing, guys? Tell me if you're not getting it. If you are getting it, just please give me a thumbs up so that we can move to something else. Okay, some people are getting this thing. They are actually getting this thing. Yeah, okay, we can move. Those who are not getting it, please just unmute yourself and ask a question so that we can move. If we can't move, I can't move without making sure that everyone gets this thing, because it is very important that you get this as it is coming when it is needed. I don't teach something that's not coming most of the time. I usually jump things that are not coming. I don't usually make effort to things that are useless. Anyone who's not getting it, just unmute yourself and ask a question. Okay. I will just assume that everyone is getting it. If not, please hold your peace. Or if you if you're still copying, then I can give you just a few minutes. Okay, Mbali.
I wanted to ask, like, it's going to sound stupid. The difference on why it was 0.4, why did we calculate that one and not the 0.10? Why does it stay the same? Why didn't we calculate it also because 0.4?
0.4, why is it not changing?
Yeah, like we did calculate 0.4, right? I'm asking now, what's the difference to O number B? Why are we not calculating it?
Or like this one?
Yeah.
Oh, I get what you mean. We actually found out that we have 7 over 10, right? And then you know that what are the factors of 7? What are the numbers that when you multiply them, you get a 7? It is just 1 times 7, right? There's nothing else.
So it's 1 in itself.
Yeah, it's 7 and it's 1 in itself. Yes, thank you. So here we are not going to get anything new. But here we have a 2 and a 2, and we got a 2 in the denominator, hence they cancelled out.
Okay.
Yeah, this one here, I can say this one because when we are writing this, we are writing this for in terms of the prime factors. You know what is a prime number? It is a number that has only two factors, 1 and itself. So 2 is a prime number because the factors of 2 is 1 and 2 only. So this 4 here, we write it as 2 times 2 to get that. And 10, what are the prime factors of 10? Factors of 10 is 1, 2, 5, and 10. But 10 have so many factors, not only 2, so it is not a prime number. 1 have only one factor, so it is not a prime number. So the only prime factors of 10 is 2 and a 5. Hence, we are saying this one is 2 times a 5. I hope you are getting this. So the only prime factors of 7 is 1 and 7. So we are not going to cancel anything out. Hence, we leave it as that. If you look at this 8 here, the prime factors of 8 is 2, 2, 2. So we're multiplying 2's out so that we can cancel things out. So we are left with 2 over 25. 5 times 5 is a 25. I hope you get this. Mbali?
Yeah, thank you.
Okay. If I am too fast, please stop me. I don't want to be too fast. Now we are done with this thing. I wanted to mention something here, and I hope you grasp it. If you have a 4 over a 10, I want you to see something here. And you have a 0.4 and you have 0.40. Oh, let me say 0 again. I want you to get this. Now, can you notice something here? First, that 4 is the same as 4,0. Do we agree on that? Yes or no? Unmute yourself and answer. Is that true? This piece here, that 4 is the same as 4.0.
Yes. Yes.
I want to see those who attended my class because I did say this in class. 4 is equal to 4.0. It is equal to 4.00. It is equal to 4.000000. As long as there is no non-zero number after the decimal, these two things are equal. Now, like I said, 4 is the same as 4. And then you put this decimal point here, and then you have a 0 there. There's this decimal point there. And then divide by a 10. I want you to get this and make sure that you get it. Can you notice also that 4 over 10 is the same as 0.4? Please unmute yourselves, all of you, so that we can just get this. I touch it a little bit, and then we move on. Can you realize that 4 is equal to 4.0? Okay.
Yes.
Can you realize 4 over 10, which is this, 4 over 10 is the same as 0.4?
Yes.
Now, when you are dividing by 10, you are moving this decimal point to the left once. When you are dividing by 10, you are moving this decimal point that is here to the left, hence you are getting a 0.4. There's a decimal point that is here. Now, when you're dividing by 10, you are moving it to the left. So once you move it to the left, remember that we have 0, 0.4. And now 0.4 is the same as 4, you know that. So when you're moving this once, because we have 1 0 in the denominator, you move it to the left here, we end up having, this is 0.4. I want you to understand when you're dividing by 10, dividing a number or a decimal, you are moving the decimal to the left once. And then, when you multiply by a 10, we have only 1 0. Multiplication means you are moving the decimal point to the right. So 0.4 is the same as, times 10 is the same as 4 or 4.0. That's what I want you to understand. Even if we grab a calculum here, you can see that if I place a 0.4 and then you multiply by a 10, like I said, multiplication means you're moving this decimal point to the right. So we're supposed to have 4.0 or a 4. That is what we mean by multiplication and division by a 10. When you're multiplying by 100, you are moving the decimal point to the right. How many zeros here? We have 2. So we are moving the decimal point 2 times. So this one, it was here. So it's going to move from this. It's going to go from here 1, 2. So this one is supposed to be a 40. I hope you get this thing. It's not hard. When you are dividing by 100, you are moving the decimal to the left 2 times. When you're multiplying by 1,000, you're moving the decimal 3 times. That's what I want you to actually get. Let's move to, let's say 38. Like I said, addition and subtraction, you did it in the videos, so we're not gonna focus on that. So here, what I'm trying to explain here is that if, let's say, you have 0.33333, and then you multiply by 10, you are moving this decimal point here once, because we have 1 0 there, so we are moving it here. Hence, we have 3.3333. When you are multiplying by 100, multiplication means to the right. So you take this decimal point, you move it. How many times? We have 2 zeros, so we move it 2 times. You move it 1, 2, hence we have 33.333. When we are multiplying by 1,000, how many zeros? We have 3. So multiplication means we are moving to the right 3 times. This decimal point was here, so it's going to move 1, 2, 3. Hence we have 333.333. Anyone who's not getting this thing? Only this part of multiplication. Let's deal with this. Anyone who's getting it, please a thumbs up. If you are not getting it, a funny face. Let's see who is funny. Most people are getting it. Now, let's also just talk about this. What else? I think let's go to 41. Just something that I just said. This one here is this. So when you are dividing by 10, let's say you have this decimal point here. So you are moving it once to the left, so you move it here. You can see that we have 1, 2, 3, 4, 5, 6. So when you're moving it to the left, so we're going to have 1, 2, 3, 4, 5. And then it's here. Now we have 3 trees after the decimal point. Dividing by 100, divisions to the left. So how many times? How many zeros? So 2 zeros means we're moving twice. So we move here and there. Now we have 4 trees. Anyone who's also not getting this, that division, you're moving to the left. Multiplication, you're moving to the right. The number of zeros tells you how many times are you moving. Are we getting this thing? This is not hard. It's not hard at all. Are we all getting it? If I'm too fast, you can stop me. So let me just assume that all of us are actually getting this thing here. We are not left behind. I want us now to focus on something that it has 7 marks and above. It always come out in the exam, always come out in the test. Of course, it is one of the long answer questions, this one. That is what is interesting about it. Conversion of non-terminating repeating decimal numbers to rational numbers. We talked about non-terminating when we were talking about the decimals that have 3 dots at the end or have a bar at the top. So we talked about these in class, but now I want us to talk about how to convert them to to convert this decimal to rational number. It's not hard, this thing. It is very, very, very easy. You just have to pay a lot of attention to it, and then we will be able to move forward. And for this one, I want you to write these steps. I don't want you to not write them. As much as I'm gonna give you the notes, but I want you to write those steps so that you can move with me here. We're only gonna do this part, and then after doing this part, we're gonna stop, and when we meet again, we'll be dealing with exponents. Exponents to surds, logarithms to algebra, and then we go to commission and everything. The interesting part. Now, these are the simple steps that you have to write to convert non-terminating repeating decimals. Just to say repeating, you can see after the decimal that you are actually getting 3. There is a repetition that happens after the decimals. But we have 3 dots here, which means that we continue. We don't stop. We have these 3 until the end. Right. Now, these ones here, how do we convert them? Please write these steps one by one. Just write let x equal the given decimal number. Please unmute yourself so that I'm not too fast when we are actually doing this, so that I don't end up moving while you're still writing. Let's try also to make it a little bit snappy so that we are not wasting more time. Number 1, let x equal the given decimal number. If the decimal number is written with a bar on top, then rewrite it without the bar but with 3 dots at the end. This is an example, e.g. this. Please write it down. If the decimal number is written with a bar on top, then rewrite it without a bar but with the 3 dots at the end. This is the second step. Okay. Are we all done? Silence means yes. Let's move. Number 3. Multiply x by 10 to get 10x. Okay. I hope you are actually getting this thing now. Because this multiplication by 10 is actually moving the decimal. Multiplication means moving the decimal point to the right one time. Now, if 10x and x have the same digits after the decimal point, then find the difference of 10x minus x. Why are we doing this? We want to end up with the whole number on the other side of the equal sign. Wow, this is interesting. Write it down. Then the last step, which is going to be 5. Solve for x and show all your workings so that you won't lose marks. So you solve for x and show all your workings so that you won't lose the marks. Otherwise, if 10x and x do not have the same digits after the decimal point, then multiply x by 100 to get 100x. What we are actually doing here, I want you to notice here. I have an x. This decimal point here, this decimal that I have here, it is like this. This is going to be our x. And then multiplying it by 10, I am moving this point here, and then we are placing it there. And then after that, you will see that x is going to have 3333 after the decimal point. And 10x is still going to have 333 after the decimal point. So, those numbers after the decimal point are the same throughout. But if the numbers after multiplying it by 10 is still not the same between x and 10x, then we don't multiply by 10x, by 10, we multiply by 100. In other words, we are moving the decimal point 2 times. Then you find the difference between 100x minus x. Of course, you will end up getting a whole number here if the numbers after the decimal point are the same. Then you solve for x and show all your workings so that you won't lose marks if the numbers are the same. Otherwise, if the numbers are still not the same, you multiply by 1,000 and you continue in that particular fashion. Do you want us to take an example, or these steps are enough?
Yes, sir.
Okay. Are you done writing? Where are you?
Number 9.
Oh, you're number 9. Okay. Please copy it. I'm just gonna give you 3, let's say about 2 to 3 minutes to write these steps. Number 9. When you're at number 12, please tell me to turn to move up so that we can finish this. I'm just gonna give you 5 minutes. At 10:30, we start with the examples and then we'll move forward so that we can finish this part. You practice at home as much as you can. Those who haven't done the addition, subtraction, multiplication, and division of decimals, please do so, because they play a very important part of our study. But those videos, they are very clear, guys. They are so much clear. I don't think there's much explanation, but if you still don't get it, you can book an appointment, then I will deal with you. Booking an appointment is very easy. You can just tell one of our reps and say that you want to book an appointment. I think they have my number, and then we can book you an appointment, and then we explain this a little bit. If you are a rep, you are one of the reps, you don't book an appointment. You don't book an appointment. It's only people who are not reps who books appointment. You're supposed to get this if you're a rep. So that's about it. Is there anyone who's already done? Yeah, if you're a rep, you don't book an appointment. You're supposed to get this. It's only people who are not reps. Because when you're a rep, you're supposed to have the information about the class, about everything. So you're supposed to give others information. You're not supposed to be seeking for information. You're supposed to have it. I hope that's what I think. Am I wrong? I'm asking only those who are not reps, not the reps. Am I wrong, guys, to expect that the rep is supposed to have the information?
Yes, you are wrong, sir.
I'm speaking to someone who's not a rep. Who is speaking? And where is she? Yeah, I knew. If you are a rep, you're supposed to get this. I cannot have an appointment with the rep. It's something that is not supposed to happen. We're supposed to have a proper understanding. Are we done? Yeah. Siyahamba manje asilali. We don't have time. We're moving. Let's start at number. I think we're at number 13. Number 13. I'm just gonna give you this until 32 to finish this. I think 32. We'll move. Just be fast, guys, to get this. That what we are actually trying to do here. We want to move the decimal so that the numbers after the decimal point are the same between x and this something times x. So hence, if let's say when we move the comma once and the numbers are the same, we don't continue, we just solve for x. If when we do that, the number is still different after the decimal, then we continue until we find out that the numbers after the decimal point are the same. So that when we separate the two things, then when we separate these things, we just end up with a whole number. Anyone who has done up to number 17, just put a thumbs up so that we can move. You know, when it is so cold, you have to make sure that you are so fast so that you don't feel the weather. Otherwise, you will end up understanding what Limbombo Boy was doing. What is important here, people are done. And now we go to number 18. I think number 18 is just clear. What is just what I was saying. That we look at all these things and make sure that what is actually happening here is we want to make sure that all the numbers after the decimal point are the same. Copy this. I will just give you a minute. I think at that one we just start. Just copy this number 18 so that we can start with the examples. When you are done, put a thumbs up so that we can start with the examples. Maybe there, I'm not gonna rush. I'm just gonna be so slow so that at least we get what we are actually doing here, so that you understand it, and then we move forward. Digit of them. When you're done, just put a thumbs up. Once I have 5 thumbs up, then I will say that it is time for me to move and start with the examples. 1.
Say, recording, Mr. Class.
2. 2. 3. What are you saying, sir?
Recording,
To forward the recording.
Yes.
Okay, I think I will do that. I'm hoping that what I'm recording here is actually recording well. I did not test it, I just recorded. And also there is the one that is recorded on Teams. I don't know what that one usually do, but I think I trust this one that I did on the side. Either way, but the thing is this. I will find a way how to give it to you, this recording. We are done. I think majority of us are done. Now this is an example here. This example is saying convert the following non-terminating decimals to fraction. So I said the first step, what is important here is actually letting our x. So here, when we are solving this, we are going to have our x here. Our x is going to be this 0.3333. I don't have my pen today, sorry guys, but I'm trying my best here. It's going to be 0.333. That is going to be x. X for Dr. Kandi. That is why I like that variable. That's why I like to solve these x's, because that's the first alphabet of my surname. That is why I solve this. And I know that you're supposed to be actually good at this because you are taught by Dr. X, so you're supposed to be able to solve X. So the first step is actually saying we have X, which is this decimal here. The next thing is we want to move a decimal point to the right, such that, if possible, moving it so that x and that number have the same numbers after the decimal point. So if I multiply this by x, let me try, and I mean by 10, I have 10 times x. Right. Now I said multiplication means moving the dot or the decimal point to the right. So when I'm moving this here, I will have 3 point, I have 1, 2, 3, 4, then we have dots there. Can you see that the numbers after the decimal point, I have 3, 3, 3, 3, 3, and then they continue. These dots means that I have so many trees that are going forward. And then here, after the decimal point, I still have 3, 3, 3, 3, 3, 3, 3, 3, 4. Like I have 3, 3, 3, 3, and it goes until I don't know, but it keeps continuing. Now, can you see these numbers that are the same after the decimal point? Can you see that? Is there anyone who's not seeing this? Okay, we are all seeing it. The next thing that we do, we say 10x minus x, taking the big minus the small. The thing here, what I want you to actually realize is this. Even if you can say x minus 10x, the answer is still going to be the same, but I just don't want you to deal with the negative numbers. That's why I'm saying just take the big minus the small. One thing that I want you to understand here is that I have 10 x's here. When multiplying, I had this x, and now I multiply by 10. Now I have 10 of these x's. Way. Let's hope you are getting what I'm telling you. I'm not saying you are like we have 10 x's. I'm saying these x's for Dr. Kant. So we have 10 x's. So when we are having these 10 x's here, which means here we're actually having 1x. This part here is saying we have 1x. This one here is saying we have 10 x's. I don't know what it means when you have 10 x's. I don't know what it means when you have 1 x's. But for the sake of maths, I will assume that this is just 1x. This is just 10x. So here, there is an invisible 1 here. Anyone who's getting that part? If you're not getting it, please unmute yourself and say what you want to say. See people, some are getting it. Okay. No one is unmuting himself, so I assume or herself that they actually get this. So we have 3.10x. Remember, I said 10x. 10x is equal to this thing. So this 3.3, I mean it's 3.33. I don't know what am I doing here. Let me remove that to remove confusion. So 10x is the same as 3.333333333, and then we have those 3 dots. And then we go and we deal with 1x, which is 0 point, and then you have a 3, and then you have another 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 3, and you continue until the end. Now here is the thing that I want you to understand. Now that you understand how to subtract decimals, then you know what is the answer here. What is 3.33333333 minus 0.33333? What is the answer here?
Three.
Yes, we have 3.3333333, and then we continue, and then we have 0.3333. If you listened to that video, I said when you are subtracting decimals, you align this decimal point with this decimal point. That's what I said. And then you start writing this first number, second number, third number, third number, and then you go this way. And then this side, 3, 0, they are aligned. If there was any number, it was going to go this way or that way, but you align them. And 3 minus 3, that's a 0. 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 Dot and a dot, that's just a dot. 3 minus 0, that is a 3. 3.000000, that is the same as 3. So here we are having a 3 here. So 3.3333 minus 0.333, we get this 3. That is why we're multiplying by 10, so that we can remove all the numbers after the decimal point. Hence, we are having a whole number 3 here. I hope you get this part. Okay. What is 10 minus 1? What is 10 minus 1, guys?
9.
9.
So here we are actually having a 9x. 9x is equal to 3. And then of course now we want to remove this 9 here and leave this x so that we can find what is actually x. So in order to remove the number that is in front of x, what you do, you divide on both sides by the number in front of x. But because we are dividing by 9, do it on both sides. So I have to divide by 9 on both sides. So we have 9, we have a 9 in the denominator. This 9 and this 9, they cancel out. And you are left with the x in the on the left hand side. And on the right hand side, we have a 3. And you know that 3 is the same as 3 times 1. And 9 is the same as 3 times a 3. And then this 3 here, I said 3 times 1, that's what I said. And then this 3 and this 3, they cancel out, and you are left with the x is the same as 1 over a 3. Let me grab my calculator here and see if what I'm saying is the truth. If I have 0 point, I have 3, I have so many 3's such that I don't stop. I keep writing them until the end of the earth. What is actually that number there? Remember that I want to actually get what is this thing, and I want to write it in a fractional form. What is the answer? It is 1 over 3. Guess what we found? We have 1 over a 3. Can you see that? 1 over a 3, we are actually having the same thing as 0.3, and there's a little bar there, or 0.33333333333. Do you get this, guys? At least. Do you get this? If you have a question, please ask the question, or else we move to another example. Some people are getting it. I can see that others are getting it. Others are confused. You know what is nice about being confused? Sometimes you are even confused if you are confused. You just stuck in the limbo, and you don't know, am I getting this? Am I not getting this? What's gonna happen? Maybe I'll see it in the exam. If I fail, I can repeat the course. I don't think this course is gonna. I think next year they still have it. Are you still getting it? Okay. As you can see here, this is the example I was trying to do, and we're all getting it. Let's try another example now. You can see that we have 0.1 bar, and of course 0.1 bar is the same as 0.11111, and then we place 3 dots at the end. That is going to be our x. And 10x is moving the decimal point once to the right, 10 times x. So we are moving it from here to there. So we end up having 1.11111, and then we continue until Jesus comes back. Now that we are actually having this thing here, we have our 10x. So we have this 10x here, and we have this x there, and we look at these numbers after the decimal point. Can you see that there is 1111111 after the decimal point? Can you see here that we have 11111 after the decimal point? Now 10x and 10x, they have the same thing, so we can subtract them. 10x minus x, of course we get that thing here. And of course, if they have the same numbers after the decimal point, these numbers will be gone and we'll be left with this whole number, which is a 1 here. Hence we have a 1 there. And of course, x is the same as 1x. The same as 1x. I have 10 of these x's. I subtract one of these x's by getting back with him, or whatever you may think of. So you subtract this one. How many x's are left? Now we're left with 9 x's. Think about it. Mbale, are you getting this? Batabile, are you getting this? Mbali, you were saying something.
Oh, I thought you understand. I thought you were asking about do I understand this.
Or do you get it?
Yes, I must say.
Yeah. If, let's say, unmute yourself so that we can all be sure. Want to know where we're actually not getting it. Let's say you can unmute yourself, Mbali or Batabile or Ntando or whoever who's still struggling to get this. Suppose Mbali, you are having 10 x's, right?
Yes. Yes, sir.
And then you remove one of the 10 x's. How many x's do you have? You had 10 x's and you remove one.
9
what?
x's.
So you have 9 x's. Okay.
Mm.
Okay, you have had it, class. She has 9 x's. So we have these 9 x's, right? And then now we have a 1, we have a 9x. How do we remove this 9 in front of x? Come on. Bali, how do you remove a 9 before x?
How do we?
Remove the 9 in front of x.
Something to subtract.
But Tabele, do you want to say something?
Yes, sir.
Yes.
What you asked him about?
Hmm?
Oh, you remove 9 by dividing by 9 on both sides.
Thank you. Thank you, Batabil. As you can see here, I had a 9, and then I divided by 9 on both sides, and then 9 and 9 cancelled out. As you can see here, I had 9x, and then I divided by 9 on both sides, and then I ended up having 3 over 9, and then I have this. That's the same thing we did here. That's the same thing we're doing here. You divided by a 9 on this side, and also that side we divided by 9. What you do on your left, you do it on your right. So that's what we did here. Divide by 9, This 9 and 9 cancelled out, and we're left with x there, and then we have 1 over 9, and then we have this. Is there anyone who's not getting this part?
Sorry, sir.
Yes, Lenamandla, sir.
Like, ndazi bandishiye xa sendawana umfundisi but ndalokubuza like kufikelele njani into lokubana kwenziwe ii-subtractions apha like phaa ko-1,11 no-0 no nikwazi uba kufike njani phaa mfundisi.
Okay. So what we are doing here, right? We want to, okay, let me just stay here. We want to convert this non-terminating repeating decimal. Of course, 0.1 bar is the same as 0.1111111. There are so many ones, hence we just put 3 dots there. But we wanted to change this to be in a fractional form. We have a numerator and we have a denominator. That's where we wanted to go. We wanted to move from this one to there. Right. Now, if we want to move from this and there, we want to make sure that we no longer have a decimal point. So now that we don't want to have a decimal point, we want to remove the numbers after the decimal point without changing this number. So the first step is we let this thing here to be our x. Why this thing to be our x is because we want our x to be in this fractional form, to be this rational number. To have a numerator that is a whole number and a denominator that is a whole number, or the numerator that is an integer and the denominator that is an integer, something of that nature. Now, we let this x to be that number, but not written in this form. And then after that, we multiply by 10 to move this to another decimal place, so that the numbers after the decimal point are the same. Why are we subtracting? We are removing the number. Who is crying now? You're making me scared. Yeah. Why are we subtracting here, Sam? We are subtracting because we want to remove the number after the decimal point so that we deal with the whole numbers. That's why we are subtracting. Hence, we say 10 minus 1x, which is this part here. This whole thing is all about, I want to remove the numbers after the decimal point so that I can deal with the whole numbers, so that I have a numerator that is a number, not a decimal number, and the denominator that is a number, not a decimal number. That is why. And then when you are subtracting, remember that these numbers now are the same. These numbers are the same. So subtracting these numbers, you can see now I have a whole number, which is a 1 on the right, which is what we want to achieve. And now on this side, I have an x, I have 10, I have an x and an x and x. And then 10 minus 1, that is a 9. So I have 9 x's. I hope I'm not losing you even further, sir. Are we still together, sir?
Yes, sir.
Yes. And then now we have this 9x here equal to 1, which we get from here. You can even punch a calculator there and say I have a 1 point. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 minus 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You will see that you're actually left with a 1. You got a 1 there. And then to remove this 9 in front of x, remember that I have 9x. 9x. 9x is the same as 9 times x, right? Now, In order to reverse multiplication, you divide. So that is why I'm dividing by a 9. I'm reversing multiplication. I divide by 9 on this side and 9 on that side. I hope you get this. But this 9 and this 9, they cancel out, and now we're left with the x. And on the other side, I have 1 over 9, which is this 1 over 9. Are we still together?
Yes, that's what it.
Yes. So 0.4, I mean, this is still the same thing, same process. So there's no need to do us this example. This is just the same thing. Come on, guys. This is straightforward. Because we're following the same procedure we did in B, the same procedure we did in A. 0.2, of course, 0.222 is still the same procedure as we did in the previous examples. Now, let's look at 0.21. And then we have a little bar there. I want you to realize that this is the same as 0.2. I have a 2 here. I have a 1. Oh, this is a weird looking 2. I have a 2. I have a 1. And having a bar, it means I keep repeating 2 and 1. So I keep repeating 2 and 1 as I've written it here. I keep repeating 2 and 1. 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. There's a bar there. Now, when you look into this thing here, let me write this 2, 1, 2, 1, 2, 2, 1, 2, 1, 2, 1, and so forth. This is actually my x. Now, I also have 10 times. Remember that we start with the 10x, right? I hope you get this. I start with the 10x. 10x is moving this decimal point here. So I will have 10x is going to be equal to, I have 2.121, 2, 1, 2. I hope you get this, and then you have these little dots. I have 1 there. So when I'm moving this decimal point and I move it here, this 2 will be in front of the decimal point, and I will start with 1 after the decimal point. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. You get what I mean? So it's going to be 10x. Here is the thing here. When you look at the numbers after the decimal point, we start with a 2 here, but here we start with a 1. So the numbers after the decimal point here and there, they are not the same. Hence, we are not taking 10 and subtracting x from it. And then we try 100x, in other words, moving the decimal 2 times. When we are moving the decimal 2 times from here to here, we have a 10 to 21 in front of the decimal, and then we have 21, 21, 21, and so forth. And when you compare x and 100x, we have 21 after the decimal point, 21 after the decimal point, 21, 21, 21, 21. So this number after the decimal point and this number after the decimal point, they are the same. Hence, we subtract from 100x one of these x's. Right. Then after that, when we subtract, because these numbers are the same, this number after the decimal point will be gone and we'll be left with the 21. And then 100 minus 1, that's a 99. So we have 99x equal to 21. And then to remove the number in front of this is disturbing. Sorry guys. I don't know who is calling now, and I don't know why they are calling. I don't know what they want, because I don't have what they want. Okay. I hope you get this. That what is basically happening here, when I multiply only by 10, the number after the decimal is going to be 1, 2, 1, 2, 1, 2, 1, 2. But here we have 2, 1, 2, 1, so I cannot subtract 10x. I cannot subtract x from 10x. Hence, I move to 100x and end up having 21. Then now, after that, I subtract x, and then we have 100 minus 1, that's a 99. I want to remove this 99. I divide by 99 because it is in front of x, and 99x is the same as 99 times x. So I divide by 99 on both sides. Right. Now, this 99 and that 99, they cancel out. We are left with x. There is an x there. And then we have 21 divided by 99. And now we have 7 over 33. Of course, you can run with a calculator or do it manually. Because one thing that I know of is that 21 is the same as 3 times 7. That's 7, 14, 21. So it's 3 times 7. And then when it comes to 99, that is 3 times, I think it's 3 times 33, yeah. So this 3 and this 3, they cancel out, and you're left with 7 and 33. That's how we got up to this. Is there anyone who have a question so far? Of course, if you can see here, if you have a 7, I have a 7 divided by 33. Just to confirm, what am I getting? I get 0.21 bar, or 0.21212121. That's about it. Anyone who have a question, please ask your question. If you have a question, please ask your question. Are we still together, guys, in this? Okay, we're still getting it. Now, look at 0.13. Try and do it at home and understand it that this one here, we only deal with 1,000 and an x. If you have 0.123, 123, 123, 123, 123, we have 1,000x because the time is already up. When we have a 0.83, of course, you can see this one that, of course, when you have this x, you move this, you have 333, and then there is an 8 after the decimal. Here we have a 3, so we cannot take 10x and x. So we can't do that. We move and check 100. 100 we have 83.333, but now when you look at 10x and 100x, the numbers after the decimal point are the same, so we pick those two. So we say 100x minus 10x, and 100 minus 10, that's a 90x, and then here we have 83 minus 8, that is a 75, because these numbers, because they are the same, they will go away, and then we just divide by 9 on both sides, and then we get this answer. Is there any question so far? Yeah, there are so many other examples here. We have this. Try and see if you can get number F by yourself. This is actually the solution. Take a screen grab, just grab it with your phone. That is just, it takes a second. When you're grabbing a moment, you don't miss it. I think this one, you're not gonna miss it too. Those interesting moments that you usually post, I think just grab this one, and also grab number G. We have number G here. Grab number G, it takes a second also. Takes a second so that you can practice it. This is how this is done. And it takes a second, of course. Can you also grab, this is number H, just to see how to continue with it, doing this thing. Grab it also, just take a second. And also you can also look at number I. This is also the last one. Let's just end there, guys, because next time I want us to deal with the exponents. Do you have a question? Anyone have a question? If you have a question, I want to deal with it right away so that you know that when we are dealing with exponents, you understand this very well. If you don't get it, you will have reps. You can ask them. They're supposed to help you with what you should go forward to. And most of the time, we also have tutors. Our tutors are always available, guys. And those guys, they actually explain this well, and they have a lot of time. They are there for you. Make sure that you use them as much as you can. Let's end our class there in the absence of questions. Those who did not those who did not attend the class, they actually missed out, trust me. And if you haven't watched those videos that I gave you a link of, I think you also missed something out. Please try and make sure that you watch those videos as much as you can. Thank you very much, guys. I'll see you in our next class. Today, I think the next class is supposed to be today, right? Mbali? Where's Mbilu? And where's Mbali? What's happening with our class today? The next one.
I don't know. I think we're supposed to have a class move on 11. I think 11:45. Yeah, counting. I don't know.
Okay. Okay, it's fine. Where's Mbilu?
Mbilu is supposed to be here. I don't know.
Okay. Okay, sure. Class adjourned. Is it the right word? I always like the closed one. I don't like the end. It's not ending. We're closing it for a moment. We still have another class tomorrow. It's not closing. It's not ending, I mean. Okay, sure, guys. I'll see you in our next class. Is it tomorrow? I don't know. But in our next class.
Is it in contact or online?
When? Tomorrow?
Yeah.
The reason today we did not have in contact is because we anticipated that most students are not going to attend. And this is important. That's why we chose online, so that most students can actually get the information. Because when I'm in class, I can't record, but when I'm here, I can record.
Okay.
Yeah. But what is the weather tomorrow?
Kushush.
Definitely then it will be in contact.
Okay.
Okay, sure, guys.